Hello students, in this video we will discuss the spin orbit coupling. Okay. Now from the normal point of view, we consider the electron is revolve in orbit around the nucleus. But now we consider the electron point of view and the proton is revolve around the electrons. Okay. When the proton is revolve, then they produce a magnetic field, and this magnetic field exert a torque on the spinning electrons. Okay. Now the Hamiltonian for this system is equal to H is equal to mu dot B, where B is the magnetic field of the proton and the mu has the dipole moment of electrons. Now this magnetic field can be calculated according to the Biot-Savart law. Biot-Savart law. Okay. For this system, the magnetic field is equal to mu naught I and divide by 2r. Okay, where r is the distance between the proton and electrons, and mu naught is the free space permeability, and I is the effective current. Okay, I is the effective current, which is represented as I is equal to E divided by T. Okay, where E has the charge on protons and the T is the H time periods. Okay, now the angular momentum, the orbital angular momentum is L is equal to M or V. Okay, and where V is equal to, we know, S divided by T, and where S is the circumference of this circle. Okay, or the distance of the this circles. Now this is equal to 2 pi R divided by T. Now we put here, then we will get M R, and the value of this is 2 pi R divided by T. Okay, this is equal to 2 pi M R square divided by T. Okay, now we will find the current, then we will multiply both side E, and this is equal to 2 pi M R square E divided by T. E divided by T is the effective current. Okay, then the I is equal to EL divided by 2 pi M R square. We divide this term into this side. Okay, then we will get the I. This is I, effective current. Now we will put this current into the Biot-Savart law to this system. Okay, and then we will get B is equal to mu naught divided by 2 pi 2R into the value of current is EL and 2 pi divided by M R square. Okay, now we simplify this term, and then this is equal to mu naught EL divided by 4 pi M R cubes. Okay, this R and R here. Then we will put here the value of the, we know the C is equal to 1 over mu naught epsilon naught and root. Okay, squaring both sides, then is equal to mu naught and epsilon naught, and we find the value of the mu naught is equal to 1 over C square and epsilon naught. Now then we will put here again the value of the mu naught, then this is equal to 1 over 4 pi epsilon naught we will put the value of this, and E into m c square r cube into L. Okay, this is the value of the magnetic field when the proton is revolved around the electrons. Okay, since the magnetic field and the L is parallel, okay, because this is a positive quantity. Now this show that these two are parallel. Okay, they both have the same directions though, and this is the magnetic dipole moment of the electrons. The magnetic dipole moment of the spinning charge, this is a spinning charge, is related to its angular momentum. Okay, and the proportionality constants here is the gyromagnetic ratio. Okay, now we will find the gyromagnetic ratio, then we will consider a ring of mass m and charge q. Okay, this is a ring and its mass is m and charge is q. Okay, and its radius is r. Okay, and they revolve like this. Now then its angular momentum is equal to the spin angular momentum. The spin angular momentum is represented by S is equal to its moment of inertia and angular velocity. Okay, now the moment of inertia for a ring is equal to mr square. Okay, and angular velocity is equal to 2 pi divided by t. Okay, then we simplify this. This is equal to 2 pi mr square divided by t. Okay, so then the gyromagnetic ratio, is mu divided by S. Mu divided by S is the geometric ratio. Then the mu is equal to, we will find the value of the mu is q phi r square divided by t. This is the value of the mu, and the value of the S is this one. And now we can write this is like this. Okay, is 2 pi divided by mr square. Okay, so then the t is cancelled to 3, the pi is cancelled to pi, the r square is cancelled to the r, and then the mu divided by S is equal to q divided by 2m. Okay, and the gyromagnetic ratio is the independent of the r and the t, the x time period. Whatever is the size of the ring, they are the independent of r. Okay, but only dependent the mass and the charge on the rings. Okay, when the charge, this charge is negative, then the direction of the mu and S are opposites. Okay, and this is a quantum value. Now the classical magnetic moment of the electrons, the classical magnetic moment of electrons is equal to mu naught mu e, this is for electrons, is equal to minus e divided by m into s. Okay, and this is a classical value. See, the its value is the twice of the quantum value. Okay, here in the division is 2, and then this value is the twice of the quantum value. Okay, due to the relativistic theory. Okay, now we know the Hamiltonian is equal to minus mu dot b. Okay, then we will put the value of the mu in b, then the value of the b is equal to minus 1 over 4 pi epsilon naught and E divided by m square, not only m, c square, and r cube, and L into the value of mu is minus A divided by m into S. We put the value of mu, this value, okay, into S. Then the Hamiltonian is now we simplify these equations, then is E square divided by 4 pi epsilon naught and then 1 over m square, this m multiplied to this m square, c square, r cube, and L is coupling, L dot S. Okay, but there is a serious spread in this calculations. Okay, due to the rest frame, but it is accelerate is the electron orbit around the nucleus. Okay, we consider the frame of the electron at rest, but it is accelerate. There is a serious spread in this calculations though. Okay, now we make some correction to this Hamiltonian, and this correction is the kinematic correction to this Hamiltonian is known as Thomas precisions. Okay, is Thomas precisions. Then the Hamiltonian is equal to the Hamiltonian, the spin orbit, this is means spin orbit, okay, is equal to E square divided by 8 pi epsilon naught and 1 over m square, c square, r cube, and Ls coupling. Okay, here we put the quantum value, that's why this is 8, and here the value of the classical, this is 4 pi epsilon naught. Okay, and this is the spin orbit interaction. So, and the spin orbit interaction does not commute with L and S. Okay, the S dash SO is spin orbit Hamiltonian is does not commute with the L and also with the S, is not equal to 0. There is some error, like, okay, there is some uncertainty, this is not equal to 0. Now then the spin in the orbital angular momentum is not conserved. Okay, this spin, this is a spin, and this is the orbital angular momentum are not conserved, but the Hamiltonian of the spin orbiting is commute with the L square and the S square. Okay, they are commutes too. Now then in the next video we will discuss the its remaining part. Okay, thank you.